Let's look at two examples. One of these examples is a less than example, and the other one's a greater than example. And what a lot of teachers will tell students as an easy way to remember, less than, you can think of this little way of remembering it. It's less than, it sounds like and, okay? And when it's greater, okay, you probably heard me say that, greater, it's an or, okay? Okay, so what do I mean by and or? Well, a geometric way of understanding this, okay, we're going to do the algebra method, but I just want to show you geometrically, when you look at the difference between two numbers, you're really talking about the distance between the two numbers. So if we look at the number line, here's the number 2, the distance between some number and 2 has to be less than 4 units. Now you could be 4 units to the right, you could be 4 units to the left. So that would put you basically less than means closer to, right, the number 2. So less than, that distance has to be less than 4 units. Okay, so you're closer to 2 than 4 units away. So this is the graphic, okay, or geometric interpretation, and this is basically saying that x has to be greater than -2 and, okay, and at the same time it has to be less than 6. It has to be in between those two. Now you don't have to do that for every problem, and sometimes it's hard to graph some of these because they're a lot more complicated than this. But the way I would do it algebraically is like this. If I had a less than inequality, okay, absolute value inequality, what I would do is I would write it as a compound inequality. I would say whatever's in the absolute value is less than 4, and, remember less than, and it's greater than the opposite of 4. Okay, so x minus 2 is in between those two, the negative and the positive value. Then we're just trying to solve for x. We're trying to get it by itself. So we're going to add 2 to the right, the middle, and the left. And if we do that, we get -2 is less than x is less than 6. The same thing we got here by analyzing it geometrically. So x is greater than -2 and less than 6. So remember, less than and you can write it as a compound inequality and just do it like we did this one. Let's look at an or one now. Same geometric interpretation. Basically, we have the distance between some number and 2. Difference means the distance between some number and 2 is greater than 4 units away. So greater, of course, means further away, right? Greater than 4 units away. Okay, so you're going to be like this. Okay, so now if we saw this on a number line, we would write x is less than -2 or x is greater than 6, greater, right? Now like I said before, like you might have a more complicated problem than this. It might not be so easy to graph it like I just did. So what you can do is you can use this algebra way of solving it. You're just going to split it up into two inequalities. X minus 2 is greater than 4, or x minus 2 is less than -4. Oh, wait a second. What did I do right there? I switched the inequality sign and I switched the sign of this number to the opposite. Okay, now you might be wondering, okay, why did I do that? And let me see if I can explain. Whatever's in the absolute value, originally, before we took the absolute value, right, making it positive, this could have been negative or it could have been positive. Now we're working backwards to find out what x was originally before we took the absolute value. And so what you can do is you can go like this. You can say whatever was in the absolute value, we're considering the positive scenario, or it could have been the opposite. See, the negative, the opposite of that quantity. So all I did was I took whatever's in absolute value, I considered the positive case and the negative case. Now, if I multiply both sides by -1, what happens to the inequality sign? It changes direction, and this changes to a -4, and then this becomes x minus 2 because the negatives cancel out. So that's what brings us to this step here. A lot of times teachers, they don't talk about that particular aspect of it, and I think sometimes students think like they missed something somewhere. But basically, originally this could have been a positive quantity or a negative quantity, and we're working backwards to figure out what x was before we took that absolute value. So we're considering both. Okay, so if we add 2 to both sides, we get x is greater than 6, or add 2 to both sides, we get x is less than -2, greater. So you want to put that or in there, and when you graph it, you're less than this value or you're greater than that value. In math, or actually means both. So this is the set of all points that make this true, combined with, right, or means both, combined with all the points in this region will make this inequality true. Okay, whereas and actually means intersection. It's the overlap, okay, between all the points that are less than 6. Okay, that's all of these points. And the intersection of all the points that are greater than -2. And means intersection. It's just these points.